Good afternoon, everybody. Welcome to a very special GeoStrata Extra, the Halloween edition, where we dress up in costumes that are maybe too obscure for people to guess and have a good time. I am GI Director Brad Keeler, today posing as the mayor of Flavortown, Guy Fieri from the Food Network. Thanks everybody for joining us. As you may know, we do GeoStrata Extra once every issue of GeoStrata. We pick an article or a piece from the current issue and do an extended interview with the author. Today is special because we're going back in time to 2017, where Mark Seel, Mary Nodine's guest today, wrote a piece about Alcatraz. We figured since that was spooky, and we like spooky things, and we hope you do too, that it was appropriate for Halloween. So thank you for joining us. If you don't know anything about the Geo-Institute, we're a member society of geotechnical engineers and geologists. We have about 12,000 members. We're part of the American Society of Civil Engineers. There's a lot more great content on our YouTube channel. Click subscribe, click get notifications. You will be in the know whenever we put out anything new. Now, let's get spooky. I'm going to turn it over to GeoStrata Editor Mary Nodine, who's going to tell us what we're going to do for the rest of the afternoon. Mary?
Thank you, Brad. And thank you everyone for bearing with us there. Well, we had a ghost who was stealing Mark's sound for a little while there. We had to work that out. So welcome to the special Halloween edition of GeoStrata Extra. As Brad said, in this series, one of our editors, and that's me today, interviews an author of an article of one of the issues. We've been doing articles that are in recently published issues, but we thought it would be fun to go back to 2017 and do a special Halloween edition for Mark's article on Alcatraz. So we're going to go back in time and talk to Mark Seel, who authored the article Stabilizing the Cliffs of Alcatraz Island. It may be the rock, but it still needs attention. So this was a fascinating article, and we thought it would be fun to revisit it for the occasion. So as Brad said, my name is Mary. I'm a project manager with GEI Consultants in Woburn, Massachusetts, and I've been an editor of GeoStrata for 4 years and the author of the GeoPoet column since 2008. Mark Seel here is a practitioner of geological and geotechnical engineering, being licensed in both geology and engineering. He's a partner and senior practice leader with Langen Engineering and Environmental Services in New Jersey. And over the last 30 years, Mark's practice has taken him to many areas of the country as well as overseas. His experience and core areas of expertise include design and construction related consulting on land development projects such as deep foundations and deep excavations, as well as assessing and stabilizing geological hazards, including rock slopes, slides, embankments, and abandoned underground mines. That sounds spooky too. Mark has been an active and contributing member of several technical and non-technical professional organizations and has been on the GeoStrata editorial board since 2016. So in this installation of GeoStrata Extra, we are going to delve deeper into Mark's article by asking him some probing questions and see if we can get more details on the history of the island and how it pertains to the engineering work that he did there. If you have questions for Mark, I encourage you to type them into the comments on this video while you watch, and we will do our best to address them as time allows. Welcome, Mark. So, first, for those of you who may not have read the article or haven't read it in a while, can you give a brief synopsis of the project and the work that you did there? I know you have some images to share as well that can help set the scene.
Yes, thank you, Mary, and thank you, Brad. Glad to be here and talk about a favorite topic of mine. So just kind of big picture from 30,000 feet or so, the project itself, it began some 20 years ago or so when park representatives found that rocks were falling at the base of the cliff that's at the parade grounds at the south end of the island, and noticed that the accumulations were happening over time. So there's some intervention of sorts that were probably needed. They embarked upon a journey to start that process. We've been involved in the island and working at the island for several years. We've been brought in through Miss Channy Elsner through Untitled Martin on this project with our partner out in California, Richard Rogers. And they've been involved in the project for many, many years, and then brought me in around 2010 or so to get my take on the geological aspects and stabilizing the cliff. So after we completed that work, we had, during the completion of that work, we had Jane Elliott from our office also was integral in overseeing a lot of that work. So what it generally entailed is stabilizing the cliff. And what we ended up choosing as the right method was a combination of high-strength rock anchors and bolts with a shotcrete beside. So pneumatically applied concrete in a structural application about roughly 6 or 8 inches thick. And then the rock bolts were applied on top of that. And then above that was a plain concrete layer, 4 to 6 inches thick, that was then made to be decorative. So it was tinted and sculpted to try to match the surrounding formation. It was done in a few different phases because of funding and scheduling issues. We couldn't do everything all at one time, so we kind of prioritized areas around the cliff, and then we went at it from that approach. And so far, there's been 2 of 3 planned phases have been implemented to date.
Very cool. I know that you have some project plans and maybe some photos you could share with us to kind of explain what you were doing out there. If you could pull those up, that would be awesome for the viewers, I think. And I just muted you, so you have to unmute yourself if you want to talk again.
There we go. So I'll get the buttons right eventually. So there's the mute button, and I'm going to share my screen with folks.
There you go.
And hopefully you're able to see a nice aerial image
Perfect.
of Alcatraz. All right. So this is the end of the island that we're referring to. So this is the south end of the island. These are the parade grounds. And here's the cliff in question, about 60 feet tall. It's comprised of a sandstone member, and this here in white is the Wardens House. So the Wardens House, since it's an isolated island, it's the warden was not coming to the island every day. They actually created a residence for him. For the various wardens that occupied the space. That was built over here, and then the main cell block is back here to the upper right, and then these other buildings had various uses. Let me open this a little bit wider for everybody, and give you a quick plan view of the island. So here again is the parade grounds down in this end. This area around here is the subject of the topic that we wrote on and that we're discussing today. Again, the Cell House building in the back, recreation, and other buildings around the island. One of the things it's not you don't see today is what the history is, and it started out as a lighthouse, and then very quickly became a fortification and a military prison in the late 1800s before being converted into a federal penitentiary in the early 1930s. So again, here's just discussing what we did. Is our charge was to characterize the rock mass beneath the Warden's ruins, and then based on that characterization, we would then come up with some options for stabilizing the rock. And again, as I mentioned, there was, we've found through our work that there's areas that needed attention, and we came at it in different phases. So what we're showing here in these red lines is these traverse lines, basically. So we're collecting linear data along the rock, and then we would, and then later, what we did is we did some 3-dimensional laser scanning, and this is just a still image, a colored still image of the laser scanning the parade grounds. And that helps inform us of a variety of things, not just jointing and patterns, but also it's a good basis for the design and construction documents.
Yeah, what's amazing to me about this and that I didn't understand fully when I first read the article is that the parade grounds was something, it's not like it's a natural feature. The parade grounds was something that they were, I think, planning to level the island and then just like blasted it out. And then they're like, oh no, we're just going to stop here. And, but it's like when you look at an aerial view, it's pretty clear that that slope does not look like it's really going to be in place for the long haul.
Right, and the rock is actually pretty good, and what we found is the structure. It's a structurally dominated rock, but there was no gross or large scale features that would create very large hazards. So it was really more of a block type failures, and so it just kind of unraveled over time, and that's what it was identified early on. But you're right, a lot of excavation did happen on this island to get it to the shape that it's in today.
Yeah.
So this plan here just shows I've kind of highlighted in red these areas in red are the first two areas, which was phase 1, and then this area over here would be phase 2, as what we're showing. And then what does that look like from the parade grounds? This is the area to be stabilized, and this is one of the red areas that I shown on the last image. And this one is on the other side. And so there's another really cool feature here that I can show you, which maybe I'll have to come back to it while it reloads. So we'll come back to that, but it's a really cool image of our 3D laser scanning that we did, because I showed you the still image, which gave you a pretty good sense, but there's other tools that you can use to navigate around it, right? So, and then after, in this, keep in mind that some of this work took place over many years. So the images I'm showing you now are really have taken place over the course of about 5 or 6 years, from the final characterization into the construction. And if you'd like, I can walk you through some of the construction photos right now. Mary, is that?
Yeah, that would be great.
Okay. So, what we did is, I'd mentioned earlier that one of the benefits of the laser scanning is that we can use it for construction documents. So what this image shows here are a couple of typical profiles or cross sections. What you see in the shading area is really the point cloud. So it's a point cloud that shows it's an actual representation of the slope geometry at those specific locations. And from there, we can create these fairly detailed depictions of what we're trying to accomplish with our design. And it shows some rock anchors and a spacing, the type of rock anchors that we're using, type of shotcrete, etc. Here we have some details, and we're trying to really accomplish many things, which I'll come back to later in this review. Is what I wanted to draw your attention to here is we're showing this planter detail. So we're trying to create crags in the shotcrete that allow soils to accumulate and vegetation to take.
Can you zoom in on that more?
I sure can.
There you go.
So.
Interesting.
So please drive. It's easy for me to see. I appreciate your comments on that. So this is just showing some of our structural shotcrete, our dental shotcrete, which are our plain shotcrete, and then the idea here is to show, and the size of these planters varied significantly, but it was part of the overall scheme for reproducing or reviving the cliffs to make it.
Right, and I understand you had to hire like a sort of artistic person to actually design this shotcrete facing. It wasn't just a standard shotcrete facing that we would do for a soil nail wall, correct?
Yes, that's right. So in a sense, it was done in a couple phases. We took care of the design of the structural shotcrete and the thickness of the plain shotcrete, but the one thing that was still needed yet is to come up with matching the color of the shotcrete, the final color, which would be tinted and sculpted, putting joints into it to match the surroundings. And Boulderscapes is a company that's that leads the way in this initiative and they're located out in California as well. And so they were brought in to consult and work with us and the design team on coming up with the strategy for that. So there was test panels that were shot, and the client, the owner, was involved in selecting a certain tint and sculpting that they felt best mimicked the existing or the original conditions.
Right. Yeah, that's interesting.
And
Not
you can
something,
see here on-
not your
right,
standard shotcrete well. Go ahead.
No, correct. And now this is a point cloud from our laser scanning, so you can see the pretty good amount of detail when you really zoom in here.
Oh, yeah.
You get a good sense of the texture of the rock as well. So they're very helpful in design and construction.
So you did the laser scanning, and I understand you did rappelling and kind of like more manual rock mapping earlier on, like in the early 2000s. Is that right?
That's correct. So what we did early on, and when the project first started back in the early 2000s, is there was rappelling. So what we did is we went in to collect linear data. So we would collect the mapping of discontinuity or joints and bedding. So geologists would come in and rappel down the cliff, and you would do these very detail lines, and collect data on the bedding, on the jointing, the attitude of it, the dip to direction, the length, trace length, and in any other data that you needed to glean out of here, whether it was weeping from water, dry, joints were open, etc. All that data was collected by rappelling, and then when we came back out in 2010, we did some verification of that. We also did some updating of the mapping, and then we used that data with the 3D scanning to kind of integrate all of our data and come up with help develop our design, which was a separate process, because once you have all this data, there are some options on how to go about stabilizing the cliff, and then from there we had to went through a process of through the design development process of determining what that would be. And this was ultimately chosen, and a little bit later we could talk about some of the other options that we had available to us. So here I'm just going to kind of go through a few of the construction photographs. You see this is on the west side, where rock had been cleared off, and through a series of colored dots, different size dowels of bolts or anchors were drilled into the rock at different angles, which was overseen, which was provided on the drawings, but overseen by our folks. Well, here, what I wanted to illustrate is some of the structure. I talked earlier about the jointing that we found. Well, during our assessment of that data, we did kinematic analysis. We're trying to find the most kinematically possible joint failure geometries that exist. And you can see in here, those engineering geologists, and this might be a little too tight for a wedge, but it certainly looks like a wedge, and then you get a lot of plane failure. So blocks were coming off, and some of these, some of the losses here falls were more pressure than others.
Mm-hmm.
Let's see. So here's some of the shotcreting underway, and between the structural layer and the plain shotcrete layer, there was epoxy-coated steel used to reinforce the face that was trimmed and shaped to fit the rock face. There were bars that were put in, some anchors, and some weep drains that were drilled in. You can see here in the next shot that this is the actual application of shotcrete along part of that face, roughly in the same areas the last image shows. Yeah, it was a well-controlled process by the contractor. And after you get done with part of it, there's some testing, of course, of the rock bolts and anchors, and that was all done high up on the cliff face, and people were repelled in to oversee that work and perform that work. Then here, what you can see is this is part of the cliff face again. This is after the shotcrete's applied. So it was applied. The rock jointing was notched into the plastic concrete. And then this is the tinting, and you can see in here already that there's some variability. It's not just simply one coat of color, a distinct color. There is some variability that's applied to it. It really has an artistic flair to it to try to mimic the final face. And this image here shows the other side, where this is Warden's ruins. And you can see the jointing's cut into it, and a lot more coloration. I think the color differences often have to do with the shading and time of day as well. So now that's an overview of the project for 30,000 feet.
That's pretty cool. And so in your article, you say that the mission of the National Park System was to preserve unimpaired the natural and cultural resources and values of the National Park System for the enjoyment, education, and inspiration of future generations. So I will admit that when I first read the article, I was a little wary of how a shotcrete rock facing would be able to really fit within the spirit of this mission. I guess when I've thought about the fact that the rock face was man-made in the first place, that kind of changes my opinion a little bit. But how did you work with the National Park Service to ensure that you were both maintaining the island's integrity while ensuring the safety and longevity of the park?
Sure. That was a very interesting part of the whole process that was led by the design team, structural engineer, Una Martin, the lead role on that, and helping us get through the process. It really required some vetting. And so our design team, we looked at it from, and the whole project team looked at it from different angles. And so there were several different options that we had identified. One is you could certainly apply netting, steel netting to the site, and it would have worked. And and another key the one that was ultimately selected, of course, is the shotcrete. And it's the process that I found really very, very intriguing. And really, when you look at the mission of parks, it's preserve unimpaired cultural and natural resources. It creates a conundrum on this particular project, because here you have the Wardens House ruins, which are on top of the cliff, and you have the cliff, which is eroding, and at the intersection of those two is where the rubber meets the road here, right? And how do you preserve the cultural resource, the Wardens House, without impairing the rock? Right, so it was a bit of a conundrum that everybody felt was, intrigued to come at, and so ultimately through that pretty significant vetting process, one of the things that we figured out was, okay, erosion, it's a natural process, and it's accepted as a natural process, and therefore it's part of it meets it falls into the mission of the park, and the cultural resource is something that, well, geez, if we preserve it, what era do we preserve it in? It could be preserved in its current state, which is post fire, like mid 70s, or frankly, it could be preserved to an earlier time, and so by applying that same philosophy to the rock, we say, well, okay, we've already lost some of the rock, and it's undermined the cliff, undermined the foundation of the building. So what if we are able to restore that to a different time, and in such a way that helps maintain the natural look, and ultimately that's where we ended up. We said, okay, well, shotcrete is really it's sand and cement, and sandstone is cement and sand. So texturally, it has the same appearance, and then what you needed to do would be to tint it and sculpt it to give it that look. And so, it was in that moment that it's clear that you've got a solution that will preserve unimpaired for future generations the cliff and the Wardens. So it was a very clever process that had to be gone through to get there, but it was very, very rewarding, I think, for everyone.
Yeah, I think that's a cool way to frame it, and it makes a lot of sense. Like, you can just leave things alone and let them fall apart, but or you could do some engineering and do your best to preserve it. People just don't usually think of preserving a cliff the way they think of preserving or restoring a building.
Yeah, and that was one of the challenges. And but then again, of course, it's an operating park, and folks, the owners realized, look, if we let this keep going, to your point, the better roads, it's no longer. So there's it took a little creativity to get there, but it was we got through it.
Awesome. Okay, so we have an audience question. Nick Trimble asks, if the rock was fairly sound, why was such a thorough solution used with such large rock anchors, and what other solutions were considered? So I guess this is more looking at a global stability, from a global stability standpoint.
Sure. Well, the first, thank you for your question. In the answer, it's involved the process, right? So my first thought, or the team's first thought, and in this case was high strength netting, steel netting, 150 KSI netting would work, and that system uses something called the Revolum concept, in which you're really looking at a relatively thin layer of material that needs to be restrained, and you use bolts that are torqued to at a certain spacing to do that. And the spacing might be 6, 8, 10 feet, and by using that over the high strength netting, you engage the netting, and therefore, if any rock tries to dislodge or move, so any kind of deformation then gets transferred back to the anchorage that's far deeper back in the rock. That process works really well. And so the reason that we even looked at that is, number one, you had a lot of the joints that were in the rock. Some of them were actually fairly closely spaced, so several inches to only a few feet. So it wasn't practical to rock to bolt every individual block, and so you want to rely on the natural friction and cohesion of the mass. And so in doing, one of the reasons that this the netting was even considered in the first place is because it addresses that sort of issue. And then the reason that particular application or concept didn't get pushed forward is that there's other considerations at play here. It's not simply a technical issue. It's we have an operating park. It's over 1 million visitors a year. It's very popular, and as the name of the island, Alcatraz, implies, Alcatraz literally means island of pelicans. It was coined in 1775 by a Spanish sailor, and so birds are a big part of the island, and so that had to be considered as well. So there was, as I allude to in my article, there were some ornithological issues or considerations for the design of this. And so, during the design team vetted this out and thought, well, geez, if you put the netting, how tight can the netting get to the face? And if the face is trimmed up nice and smooth, that's one thing, but that rarely ever happens, and you're not going to go through that level of effort. So you're going to have some joints or gaps that little bird feet could get caught in, and no one felt that was or everyone involved felt that was probably not a sightly thing to behold. You don't want you don't want to see the birds that roost here to die in your intervention strategy, counterproductive. So that was a big piece, because there's a lot of birds that that cormorants and western gulls, pigeon guillemot, who also roost in the nest, and because of that there was a shortened period of during time in which the work could be done. And so I mentioned earlier schedule. There's a 3-month window, basically December through February, when work can actually be done. So the birds had a big part in not only the schedule of any work, but the type of work that we did.
So were the birds completely gone for the most part during construction in those months, or were they just not nesting?
Yeah, they weren't nesting. There's a certain period of time in which they nest, they roost for their young, and then they're out. So I don't know what the habits are of some of the birds, but I'm sure gulls at least hang around all the time. So yeah, God bless you. So that was it was an interesting part of the overall construction and the attention that they got. But I think at the end of the day, it was better solution was the one that got implemented.
Right. So it seems like you might have had a more say if this was at the side of a highway, there might have been a more cost-effective and less belt and suspender solution. But because of the birds and because this is a national park, it's like you sort of went more, did a different solution than you might have otherwise. That maybe looks like it's more than was needed.
That's correct. So coming back to your point, the one that was raised, I think earlier was the it does look like a robust solution, but it was the solution that was needed to meet the park's mission.
Yeah,
you're absolutely right. Something like this you wouldn't do on the side of the highway unless the highway department really wanted to spend a lot of money on making it look nice.
Right, unless there's a highway in a national park, maybe. But one of the photos you showed, I think from towards the end of construction, there are some birds sitting on there that look pretty happy.
Yeah, they
so it seems like they like it, which is great.
Yeah, let me share that screen again. So right in here, you can see this is shortly after.
Yeah, they're like, this is our shotcrete wall.
Right, and this reminds me as well. This is an interesting. Some people out locally would call this White Island, and I'm sure if viewers could see why. If you imagine thousands of birds covering this with no impedance, there'd be they whitewashed the island.
Pretty cool. So my next question is, were there any special considerations in design to make the shotcrete resistant to degradation from the harsh saltwater environment? It seems like sort of a little bit unusual in that regard as well.
Yeah, well, there was. We evaluated the conditions. So in a marine environment, under high saline conditions, if you're building on the ground, you're probably going to want to be something like a type 5 cement with pozzolans and a water content in the 0.5 range or something like that, just to make sure that you've got as dense and chemically resistant material as you can. Now, in this application, you've got, based on the elevation, certainly it's a marine environment, but on the elevation, there's really no groundwater, so the corrosion wasn't nearly as bad. So I think type 2 cement was sufficient here with some modifiers in it, but it was definitely considered. All of the anchors were double corrosion protected for permanent resistance. So yes, it was definitely a factor. I'm sorry, Mary. I'm not hearing you.
I'm sorry. I have a small ghost I might have to attend to, so I might have to have you tell a story. But I believe there's some history regarding concrete on the island as well, right? I think you were telling me when we were talking about that they actually made some of the structures out of salt water in the concrete, which was not really advantageous for them, right?
Yeah, I'll tell you. I'll go over that. If you have to walk away, I'll just give a couple stories.
Just talk for a minute, and I will be right back in my witch splendor. Hang on.
You got it. Okay, so yeah, one of the interesting things that happened on the island, and I'm gonna bring my screen up again, is, as I mentioned earlier, the site was a former citadel, which so back in the 1800s there was go to the plan here. When the site or the island was first constructed, there was up in this area here, there was a citadel, it was a fort. So there was a fort and a military prison that was built here, and a lot of it was brick. And as you can imagine, it's very difficult to bring materials onto an island, especially one in troubled waters. And there's limited materials that are available on the island. However, there is an abundance of rock, there's some sand and other soils. But any cement had to be, or concrete would have had to have been imported. So, in the interest of making use of or repurposing the existing materials, often they used rock from the island as aggregate in concrete. They brought in cement. When they knocked down the Citadel and the old prison, they crushed that brick and they used that as aggregate. So you've got repurposed brick and some stone, and you mix it with the cement. And the one thing that's missing on this island is supply of fresh water. But there was an abundance of seawater, and so that was used to make a lot of the earlier concretes for some of these buildings. And so you imagine using salt water in your concrete. There are some durability issues that you could expect, and over time, it just some of the structures were in states of decay, and that was led ultimately, in my estimation, to the closure. You had these series of attempted breakouts. The last one in '62, and then you had the decline of physical decline of many of the structures as well, which hastened the departure of the old fortress and the creation of the new penitentiary rather, and at that point, that's the point at which they were using some of those mixed materials for construction of some of these older buildings in the current federal prison, which is like the cell house building, for example, and that kind of leads me to a ghost story if you're interested in hearing about that.
Yes, I mean, here I am in my jail cell. I've been waiting for it this entire time. So yeah, go for it.
All right. So we've already established that the island is a rock. When you built all this infrastructure on the rock, you got to carve tunnels in for utilities. In fact, a lot of the fresh water, what little fresh water there is held in cisterns that are buried underneath some of the buildings. This was going back when the penitentiary was operating. At one point, and this is probably in the late '90s, there was a need for some work in the cell house area. So there was some seismic retrofitting that had to be done. The issue was that there was crumbling concrete here and there, and new seismic codes in California had carried certain requirements with them. So ultimately what happened here is that there was a project in which we were involved in, and we did our investigation, our analysis, and we determined that some shear walls had to be installed in the cell house building, and that was going to require new, fresh concrete. So all that was imported and brought in. But I'd mentioned a moment ago about these tunnels. Well, some people call them catacombs, which is just this, I guess, in a sense, a spooky word for a tunnel. But they went underneath parts of the cell block, and that was where they ran utilities and conduit, ductwork, and water and such. And some of the planned shear walls, these new shear walls, were going to have to be built through portions of these areas. And so, as an operating park, you had to get out of there, or rather, you couldn't get in there until after the park closes. So after the people left and get out of the park, then the crews to construct would come in, and the person who was working for our folks at the time, young geotechnical engineer, no fears, very logical person. First night out there, of course, they get dropped off at whatever it is, 4:30, 5 o'clock, and then they're there through the night. And so all this work is being done under lights in the darkness, and part of this brings them into the catacombs. So. Or these tunnels, and they're hearing noises, and they're inexplicable. They can't make sense. But it was described that some of the sounds or noises that they're hearing were faint, distant voices, moaning, some odd things that couldn't be explained with by the work that was being done, the equipment that was there, the people that were present. It was just an oddity, and my understanding is that the person who was doing it, who was working, doing the inspection, Over time, he felt like, it wasn't frightened, but he felt spooked by it initially, but it just became part of the background noise, and it was constant. But they worked through it. It was an interesting idea, and just when you think about the federal penitentiary from the design perspective, the intent of it was right. It sent a lot of the most disobedient and troubled inmates. These people were not supposed to leave. So we're wondering if some of their souls or spirits still reside. There was an active morgue on the hospital, but although there were no executions at Alcatraz Island.
Yeah, but who knows? I mean, I don't think that I would have really been that excited to do night work in the cell block at Alcatraz.
Yeah, it is kind of a spooky idea, and it had probably an eerie feel, and it was not helped by the sound of noises you couldn't explain. So
no, certainly not.
I'm sure it was priceless inspection time for that person.
Yep, and I'm sure stories to tell your grandkids. That's pretty cool.
Well, tell your grandkids. That's
Great. Well, I think we'll probably close on that note. I love that this was able to fit the Halloween theme. Brad, if there's no more questions, I think we'll turn it back over to you. And thank you so much, Mark, for giving us those stories.
Appreciate it. Thank you, Mary. Thank you, Brad.
Thanks to you both for a great presentation and great questions today. And this was a lot of fun for me. When I was thinking, what can we do that would be cool for Halloween? I thought, oh, there must be some issue somewhere geotechnically with something spooky. And I Googled GEOSTRATA Alcatraz, and I got this. So I didn't even remember that we had done this article. So thanks to my late night Googling skills, and then I think I emailed Mark at about 1 a.m. saying, hey, would you be willing to do this? And then the next morning he said he was up for it, and we plowed ahead. So thanks to the audience for joining us today. If you liked what you saw,
well, I was just going to say, now you've opened the door to interviewing authors from all the way back the last 20 years of GeoStrata. So,
we totally could.
Watch out if anybody wants to see anyone interviewed from any GeoStrata old favorites. Brad's probably game.
The next one I was trying to think of is I was really sad that there's no land at the North Pole, because I thought surely we can do a special Christmas episode, but alas, there is nothing there. So that's a little bit sad. If you liked what you saw, we do GeoStrata Extra every 2 months. The next one will be for the November-December issue, and it's going to happen on December 1st. So look for details on that coming up. Our next live stream will be on November 18th, and it's going to be one in our diversity series. Menzer Pelivan of Dream Big Fame and our Outreach and Engagement Committee will be interviewing geo legend Suzanne Lacasse. So you'll want to check that out. Again, look for details on our website or on our Eventbrite page or on our YouTube channel. If you want to know when we post things, I said it at the beginning, I'll say it again, click subscribe, click get notifications. You will be all knowing. You will impress your friends with your knowledge of GI live streaming events. Everybody out there have a happy Halloween. And thanks again, Mary and Mark, for doing this today. It was a lot of fun, and I know I learned a lot. So thanks a lot.
Thank you both. Be safe, everyone.
Thank you. Happy Halloween.